Hello, hi everybody. This is the second section of Cambridge exam A level mathematics paper 3 variance 2 2023. The second part and question 9. You have to express function of x in a partial fraction. So what are we going to do? What to do is this is to interpret the function of x using the rules of partial fraction. One of the rules is that when you have a linear denominator together with a repeated root, so the function will be split into a over 1 plus the linear plus b over 2 minus x. The 2 minus x is extracted from one of the repeated root plus c over the repeated root. That is the rule. Now from here, what do you do? Look for the LCM. How do you take the LCM? The expression is 2x squared plus 17x minus 17 divided by 1 plus 2x 2 minus x all squared equated to the one you splitted earlier, 1 plus 2x plus b 2 minus x plus c 2 minus x all squared. Now the LCM of this expression, the LCM is the same thing as the original denominator of the question. That will be the LCM. Now, the function of x, don't forget to write it again here. 2x squared plus 17x minus 17 over 1 plus 2x 2 minus x. This is what we splitted to this. Now the LCM. Now the 1 plus 2x under a. If you divide the LCM by the 1 plus 2x under a, we are going to have 2 minus x squared. Now multiply by a, so which leaves us to a to bracket 2 minus x all squared. 2 minus x under b. If you divide LCM by that 2 minus x, you're going to leave all with and multiply by b. You're going to have b into bracket 1 plus 2x bracket 2 minus x. 2 minus x squared under c. Divide LCM by that. You're going to have 1 plus 2x and now multiply by c. So it leaves us with this. This denominator and this denominator are the same thing. You cancel them. So we are left with 2x squared plus 17x minus 17 equal a bracket 2 minus x all squared plus, I'll use different color for you to know where I'm going, plus for b, I'll use this color b, 1 plus 2x 2 minus x plus c, c 1 plus 2x. Now the one in black is for a, blue is for b, and kind of lilac is for c. So the one in black, the variable in black beside a, you now equate it to 0. Equate it to 0. Equate to 0. So put 2 minus x, that's the rule, equal to 0. So x will be 2. So let me call this stuff equation 1. Since x is 2, substitute x, which is 2, in equation 1. Substitute it to equation 1. So we have something like this: 2 2 square plus 17 times 2 minus 17 equal A. When you put 2 here, 2 minus 2 plus B. X is 2, it's turned to 4. 2 minus 2 plus C. 1 plus 2 times 2, 4. At the end of the day, when you simplify this on the left hand side, you're going to give us 25. The one on the right hand side, this one is 0, this one is 0, so we have 5C. So C will be equal to 5. Now the next one. So the next one, let's go to the light blue color. That's to get the value of B. A and B, they have the same one. They have a similar function beside them. 2 minus x. Skip that one first. We come back to it. Let's go to C. To get C, put what is beside C to be 0. Look at the color. That color simplify. I'm dealing with C. 1 plus 2x to be 0. So x is minus half. You repeat the same process again. Substitute x equal to minus half to equation 1. So hence we have we are done with this. Now I'm dealing with x equal to minus half. So we have 2 minus half whole square plus 17 multiplied by minus half minus 17 equal A. 2 minus half whole square plus B. For B to be 1 plus 2 times minus half brackets 2 minus half plus C 1 plus 2 times minus half. At the end of the day, when you simplify the one on the right hand side, when you simplify this, it gives us use your calculator, minus 50 over 2. Why the one on the left hand side? For B, 1 plus 2 times minus half will give us 0. So everything here will turn to 0. The same thing with C. Everything here will turn to 0. What left is 2 minus half, which is 5 over 2. 25 over 4. Yeah. Multiplied by A, we have 25 over 4A. At the end of the day, when you cross multiply, do the needful, simplify, you're going to have, when you cross multiply, we have minus 100 equal to 50A. At the end of the day, A equal to, it's not minus 100, I think it's minus 250 times 4. So A will be minus 4. That's for A. So we have A to be minus 4. We have C to be 5. Now, what is missing is B. Sorry for my rough work. I'm just managing this first. To get C, now since we know two values are known, A and C. To get B, this is what you do. You go back to equation 1. You Equation 1 is key to this question. Go back to equation 1, substitute the value of A and B to the position and compare. Let's do it. Equation 1 is 2x squared plus 17x minus 17 equal to our A is minus 4. A is minus 4. You get our A is what? Minus 4. When you expand 2 minus x squared beside A, we're going to have 4 minus 4x plus x squared. Our B, we don't know B. I'm going to write it down. I don't know B. But when you expand what is beside B, I think we're going to have probably 2 plus 3x, 2 plus 3x minus 2x squared plus C. I don't need to expand C, it's just like that. But the value of C, I know the value of C. Do you know the value of C? Yes. Value of C is 5. 1 plus 2x. What you do, you compare coefficient. You compare coefficient. Let me take 2x squared for example. I equate it to anyone with x squared on the left hand side. With x squared on the left hand side, we have x squared here, and there is minus 4 outside. So I'm going to have minus 4x squared. The same thing with b. The x squared beside b is I think it's minus 2b x squared. There's no x squared here, so we're going to divide all through by x squared. When you divide all through by x squared, we have 2 equal to minus 4 minus 2b. We arrange, here is 6 equal to minus 2b. At the end of the day, b is minus 3. Now we successfully find the value of A, B, and C. So hence the function x, which is 2x squared plus 17x minus 17 over 1 plus 2x, 2 minus x all squared, can be written as, remember that our A is minus 4, right? Can be written as minus 4 over 1 plus 2x. Our B is minus 3 over 2 minus x, and our C is 5 plus 5c over 2 minus x all squared. That's the answer for the partial fraction. I hope you understand. Now the next part of it, so we have to integrate the function of x. We have to show that function of h, which is the partial fraction, is equal to 5 over 2 minus ln 72. Remember that function of x from the previous part has been splitted into minus 4 over 1 plus 2x minus 3 over 2 minus x plus 5 over 2 minus x. So we have to integrate it now. So the question is to integrate function of x dx with the limit, upper limit 1 and 0, and we must get this answer. So how do you go about that? Now, so let's write to be integral function of x. We have 1 to be minus 4 over 1 plus 2x minus integral, is minus 3. So I brought the minus outside, 2 minus x, and the last one, 5 over 2 minus x all square dx. The limits are 1 and 0. So the limits are 1 and 0. Let's see the page given to us, just one page. Now, how do you integrate the first one? Integral of minus 4 over 1 plus 2x. Remember this integral, NB. The integral of 1 over 1 plus x dx will give us lane 1 plus x. Do you know why it's lane 1 plus x? The reason is that when you differentiate the denominator 1 plus x, it gives us 1. And what is on top is 1. So whenever you differentiate the denominator and the answer gives you what is on top or what is on the numerator, so your answer take lane of the denominator. Is a rule in calculus. Now to do this, and to make the work easier, let's bring minus 4 outside. When you bring minus 4 outside, what will be left will be integral of 1 over 1 plus 2x. The same thing with 3. Let's bring 3 outside. What will be left is 1 over 2 minus x. Let's bring 5 outside. What will be left is 1 over 2 minus x all square with respect to dx. So from here, now from what I explained earlier, when you differentiate 1 plus 2x, the answer will give you 2. But in this expression, what is on top is 1. So you need to amalgamate. Now our aim is to get 2 on top, so the work can be easier for us. But in this expression, what is on the numerator? The numerator is 1, not 2. So when you put 2 here, so then you have to divide the expression 2 by 2 to be the same. Now the same thing with the second expression. Now the second expression, this, when you differentiate the denominator, you're going to have minus 1. And what is on the numerator is 1. So you have to attach minus 1 on top and divide the whole expression by minus 1. That's the logic. So this one is different. The third expression here, 5 integral 1 over 2 minus x squared, is different from the other first two expressions. We are not going to integrate it like that. I'll tell you what to do when you get there. Now this minus 4 over 2 will give us minus 2. Remember now, when you differentiate this denominator here, 1 plus 2x, we have 2. And what is on top? 1 times 2 is 2. So the expression, the answer will give us lane 1 plus 2x. Minus 3 over minus 1, that gives us plus 3. And when you differentiate 2 minus x, we have minus 1. And what is at the numerator now is minus 1. So the answer will give us lane 2 minus x. Plus, this third expression is not like that. You are going to integrate it in a different form. 5 integral 1 over 2 minus x can be written as 2 minus x raised to the power minus 2 x. Why are we not doing that? Because of the power. It has the power 2. You to obey this form. So at the end of the day, we have, we have something like this. We have minus 2 lane 1 plus 2x plus 3 lane 2 minus x plus 5. When you integrate 2 minus x raised to the power minus 2, we're going to have 2 minus x minus 2 plus 1 over minus 2 plus 1 multiplied by 1 over minus 1. That's how to integrate a function in a bracket. Let me give you the expression somewhere here. To integrate, let me just put that NB. To integrate ax plus b raised to the power n to be ax plus b raised to the power n plus 1 all over n plus 1 multiplied by 1 over differentiation of what is in the bracket ax plus b. That is how that would apply here. So take note of that. At the end of the day, we have minus 2 lane 1 plus 2x. I hope I'm not wasting our space. I think we are here. Plus 3 lane 2 minus x. Now this one, at the end of the day, this one we're going to have 5 minus 2 plus 1 is minus 1. Minus 2 minus 1 is minus 1 is plus. Okay, I think at the end of the day here, we're going to have something like plus 5 over 2 minus x. At the end of the day, because minus 2 plus 1 is minus 1, so we're going to have something like this. Yeah. Don't forget to substitute the limit 1 and 0. When x is 1, so we have minus 2 lane 3. When x is 1 plus 3 lane 1 plus when x is 1, this one will give us 5. You now subtract it from when x is 0. When x is 0, that will be minus 2 lane 1 plus 3 lane 2 when x is 0. When x is 0 plus 5 over 2. So at the end of the day, so we have lane 1 is always 0, so all this one will be 0. Lane 1 is always 0, all this one will be 0. What we're left with is minus 2 lane 3 plus 5, opening bracket here by minus 3 lane 2 minus 5 over 2. Now let's play with this expression so we can prove what they ask us to prove. Now here we have minus 2 lane 3, which can be, okay, let's do like this. Let me do like this. minus 2 lane 3 minus 3 lane 2 plus 5 minus 5 over 2. That should be correct, right? Plus 5 minus 5 over 2. So in this place, minus is common. So I can have 2 lane 3 plus 3 lane 2 plus 5 minus 5 over 2. That's 10 minus 5. That gives 5 over 2. So at the end of the day, we have minus 2 lane 3 can be written as lane 3 square. 3 lane 2 can be written as lane 2 cube. Your law of logarithms plus 5 over 2. So here we have minus lane 3 square is 9. Lane 2 cube is lane 8 plus 5 over 2. The minus is still outside. Don't forget your law. This one means lane 9 times 8 because it's multiplication plus 5 over 2. So at the end of the day, we have minus lane 9 times 8 is 72 plus 5 over 2, which can be written as 5 over 2 minus lane 72. This is what they asked us to put. I hope you understand it. That's the next question, number 10. In this diagram, we have to find the exact coordinate of M. When you check the diagram, M falls on the negative side of X and positive value of Y. So which means we expect to get a negative value for X and a positive value for Y. So we are asked to find the coordinate of the maximum point. Now the expression is like a product form, x plus 5 multiplied by square root of 3 minus 2x. So to find the maximum point, we need to differentiate using product rule, or you need to first find the stationary point. How do you find the stationary point? Differentiate using product rule, equate your value of dy dx to 0, and the value of x will be the maximum point. Since they said the point is maximum, you don't need to test it further. Now, so the function is y equal x plus 5 multiplied by square root of 3 minus 2x. So dy dx using product rule will be, put down the first function x plus y and differentiate the second function. The second function is square root of 3 minus 2x plus, put down the second function, and differentiate the first function. That's product 2. So hence the y dx is equal to x plus 5. Now when you differentiate 3 minus 2x raised to the power half, you know the rules, that will be half. Half come to the back of 3 minus 2x, subtract 1 from half, give us minus half, then multiply it by differentiation of what is inside the bracket, that's minus 2, plus you put down square root of 3 minus 2x, you differentiate x plus 5, which is 1. At the end of the day, the value of the y dx is equal to, these 2 can cancel this 2. So we left with minus x plus 5 multiplied by 1 over 3 minus 2x raised to power half plus this is square root of 3 minus 2x times 1. We have that. At the end of the day, so our dy dx will be minus x plus 5 over square root of 3 minus 2x plus square root of 3 minus 2x. These are dy dx. Since we are looking for maximum point, you put dy dx to be 0. At the end of the day, we now have minus x plus 5 over square root of 3 minus 2x equal minus square root of 3 minus 2x. So the minus cancel out this minus. When you cross multiply, we have x plus 5 equal to square root of 3 minus 2x all squared if cross multiply. So square cancels square root. So we have x plus 5. Oh, I'm wasting space. Equal to 3 minus 2x. So at the end of the day, 3x equal to minus 2. So x is minus 2 over 3. This is the maximum point. But the question asks us to find the exact coordinate of M. So you have to get xy. The value of x is minus 2 over 3. So let's get the value of y. To get the value of y, substitute x in the equation. Y is x plus 5. X is minus 2 over 3 plus 5 bracket square root of 3 minus 2 over x, and x is minus 2 over 3. At the end of the day, y will be minus 2 over 3 plus 5. I think we have 13 over 3 multiplied by square root of 3 plus 4 over 3, which give us 13 over 3 multiplied by 3 times 3 is 9 plus multiplied by square root of 13 over 3. At the end of the day, the coordinate of y is 13 root 13 all over 9. This is the coordinate of the maximum point on the graph. Thank you. The next question, B. Using the substitution u minus 2x, find by integration the area of the shaded region bounded by the curve x-axis. Giving your answer in the form of a with 13, where a is the rational number. You still have one page to solve this question. Now, area bounded by the curve on the x-axis. Now, the curve is bounded by the curve on x-axis, which means that we are going to equate the curve f of x to be 0 because it's bounded by the curve on x-axis, so you can get the value of x. And the curve is x plus 5 square root of 3 minus 2x equal to 0. It's like a quadratic equation such that x will be minus 5 or square root of 3 minus 2x will equal to 0. At the end of the day, x will be minus 5 or x is 3 over 2. We said using substitution, find by integration the area. To find area by integration, that will be area of y dx b to a. So integral, the b is the upper limit 3 over 2. lower limit is minus 5, and y is x plus 5 square root of 3 minus 2x dx. That's y. So let me divide this into 2. So the space will be enough. So from here, since we have to put u to be 3 minus 2x down on the side. Equation 1, u is 3 minus 2x. Then u plus 2x equal to 3, right? So u minus 3 over 2 will give us x. Since u is that, x is this. So we need x, and also we need to convert this dx to du. That's another one. So since u is 3 minus 2x, du dx is minus 2. When you cross multiply, the x will be minus the u over 2 minus the u over 2. That's equation 3. We're also going to change our x upper limits to be in terms of u. This and this must be in terms of u. So okay, okay, since u is 3 minus 2x, when x is 3 over 2, what is u? U is 3 minus 2 times 3 over 2. U give us 0. And when x is minus 5, what's u? Sorry, let me make it clear. When x is minus 5, sorry, I still need to clean it. Okay, I can do it properly now. Jeez. So when x is minus 5, u is 3 minus 2 times minus 5. It gives us minus 13. So nth. So we can now remember, let's go back our integral. Remember that 3 over 2 has turned to the upper limit. This is 13. The upper limit in this case has turned to lower limit 0, and the former lower limit has given us upper limit. I'll tell you the implication of that. And remember, we have x plus 5. Remember, we have x plus 5, and x, our new x, is u minus 3 over 2. X plus 5 plus 5. Remember, 3 minus 2x is u, turned to u, multiplied by the x. The x is now minus the u over 2. Okay, great. Now remember that the upper limit, the former upper limit at x is now the lower limit at u, and former lower limit at x is now the upper limit for x. So this is the rule. In that case, this is what we do. If should take note of this. If you have a function integral ba f of x dx, once the upper limit has been swapped to become lower and lower is now upper, the expression will become this. You need to take note of this, it's very important. So which means I'm going to apply minus to the new expression. Now be negative integral 13 0. Now u minus 3 plus 5 should give us something like what do you have there? 2 times 5, 10. That's 10. Let me check whether my expression for x is correct. 2x. Oh, it's 3 minus u, this place. 3 minus u, not u minus 3. 3 minus u. 3 minus u. So it's 3 minus u. Minus u. So at the end of the day, we have 2 times 5, 10, 13 minus u over 2 multiplied by u raised to the power half multiplied by minus half du, which can be written out. This minus half, you can bring it out. 2 times 2 is 4. At the end of the day, we have minus 1 over 4 out. Integral of 13 0, 13 minus u multiplied by u raised to the power half du. So from here, minus times minus is plus. Open the bracket. So we have 1 over 4 integral 13 to 0. When you open the bracket, that's 13 u to half minus u 3 over 2 du. So 1 over 4. Now let's integrate. When integrate, we have 13u raised to the power 3 over 2 all over 3 over 2 minus u raised to the power 5 over 2 over 5 over 2. So here we have 1 over 4, 2 over 3, u raised to the power 3 over 2 minus 2 over 5, u raised to the power 5 over 2. Open the bracket by 1 over 4. When you open the bracket 1 over 4, we have 1 over 6, 1 over 6 u, 3 over 2 minus 1 over 10, u 5 over 2. When you open the bracket by that. So don't forget the substitution, the limit 13 and 0. When u is 13, that will be 1 over 6 square root of 13 raised to the power 3 minus 1 over 10 square root of 13 raised to the power 5. That's when u is 13. Minus when u is 0, everything there becomes 0. When you check this place, root 13 cube is common. So what left here? Root 13 cube is common. What left here is 1 over 6. What is left here is 1 over 10 root 13 square. I believe I'm making sense. Sorry about my writing. Root 13 cube, if you use your calculator, will give us 13 root 13 is 1 over 6 minus root 13 square is 13, so we have 13 over 10. So it's 13 over 10. Yes. Coming with 13 cube, we have 1 over 6. Is 3 over 2, 1 over 6. 13 cubed. Checking. There's L 1 over 6. 1 over 6, 13. There's a mistake somewhere. Oh yeah, I omitted this 13. This 2 over 3, 13. Sorry, pardon me, please. So it didn't affect this. Let me clean this, sorry. Sorry. So let me move my line back. Sorry for that. So this is 2 over 3 times 13 u raised to power 3 over 2. When you open the bracket, we have 1 over 6, 13 u 3 over 2 minus 1 over 10. Yeah, fine. Now let's do our substitution. When u is 13, so we have root 13 cubed minus 1 over 10. It's going to give us root 13 raised to power 5 minus when is 0. When u is 0, everything will give us 0. So from here we have 13 over 6. Use your calculator. Root 13 cubed will give us 13 root 13 minus 1 over 10. Root 13 raised to power 5 will give us okay, I think I should do it like this. Sorry. Now, from here, root 13 cubed is common. So root 13 cubed, bring it out. So what I have inside is 13 over 6 minus root 13 square. Yeah, 1 over 10 root 13 square. So from here, root 13 cubed will give me 13 root 13, I guess 13 root 13 into bracket 13 over 6 minus 13 over 10, which is the same thing as saying 13 times 13 root 13. When I bring 13 out here, I have 1 over 6 minus 1 over 10. At the end of the day, I have 169 root 13. 1 over 6 minus 1 over 10, your calculator should give us 1 over 15. So at the end of the day, our answer should be 169 over 15 root 13. The question says our answer should be in form of A root 13. In this case, A is 169 over 15. That's it. Let's see the next question. That will be the last question for this section. The vector question. The point A and B have position vectors 1 plus 2j, sorry, I plus 2j minus 2k and 2i minus j plus k respectively. The line L has equation R equal to what you are seeing. Show that L does not intersect the line passing through A and B. And the first one is point A and B. Now point A and B, Let's find the equation of the line for point A and B. For point A and B, equation of the line, vector equation of the line, we have this format: R equal to RA plus, let me use this, lambda AB. Vector equation of a line. The second line is L. Let's call this line AB. Let's call it maybe Q. So for line Q, the line Q has a point A and B in the direction of AB. So for line Q, we have OA. What's OA? OA is equivalent to point A. That will be 1, 2, minus 2 plus lambda AB. AB means OB minus OA. So the vector equation of line Q will most likely be 1, 2, minus 2 plus the scalar lambda OB minus OA. This is B minus A. So we're going to have 2 minus 1 and 1. This is the vector equation for the point AB. I call it line Q. I remember that line L has the equation. This is line L. This is line L. The vector equation for line L, I minus j 3. That's 1 minus 1, 3 plus mu 2 minus 3, 4. So these are the two. The question asks us to show that L do not intercept Q. Now, so for intersection, they must be equal. So for Q, if we simplify it, we have 1 plus 2 lambda, 2 minus lambda, and minus 2 plus lambda. For L, can be simplified written as 1 plus 2 mu minus 1 minus 3 mu and 3 plus 4 mu. We want to show that they do not intercept. To do that, you have to equate them first. To do that, let's equate them. Let's equate Q to be L. Q is 1 plus 2 lambda, 2 minus lambda, minus 2 plus lambda. Equate it to L. L is 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu. So let's solve. We're equating them in order to find lambda and mu, the two unknown variables. So the first part, the upper x value, let's equate the x value. 1 plus 2 lambda equal to 1 plus 2 mu. From there we have 1 cancel 1, right? 1 plus 2 lambda. Is it 2 lambda? The first one. 1, 2 minus 2. R is the equation L is 1 minus 1, 3, 2 minus 3, 4. So that's 1 OB minus OA. That's 2 minus 1 is 1. Minus 1 minus 2 minus 3. And 1 minus minus 1, that's 3. think there's an issue with our OB minus OA. Let me check it properly. This is B, 2 minus 1. Where is it? Sorry. Okay. Our OB minus OA. I think it was a mistake from my side. Is 1 minus 3 and 3. At the end of the day, we have 1 plus lambda. Here, 2 minus 3 lambda minus 2 plus 3 lambda for Q. So when you equate both of them, Q is 1 plus lambda, 2 minus 3 lambda minus 2 plus 3 lambda. This is correct. 1 plus 2 mu minus 1. This. So equating the upper one, the x value, 1 plus lambda equal to 1 plus 2 mu. 1 cancel 1. So our lambda is 2 mu. Equating the second part, the y-axis, that's 2 minus 3 lambda equal to minus 1 minus 3 mu. Already, lambda is 2 mu, right? Equal to minus 1 minus 3 mu. So here we have 2 minus 6 mu equal to minus 1 minus 3 mu. From here, we have 3 equal to 3 mu. So our mu equal to 1. If mu is 1, so lambda equal to 2. Now let's see. Now after getting the two unknown variables, let's see if they intercept or not. So what you do is you go back to the line. We have Q. Q is 1 plus lambda, and our lambda is 2. 1 plus 2, 2 minus 6, minus 2 plus 6, which give us 3 minus 4, 4. Let's look at L. Our mu is, I think is 1. That will be 1 plus 2 minus 1 minus 3, 3 plus 4, which give us 3 minus 4 and 7. Since 3 minus 4, 4 is not the same thing as 3 minus 4 and 7. So hence, they do not intersect. That's the answer. Next question, which is the last part. We have to find the position. We have to find the position of the foot of the perpendicular from A to L. From A to L, foot of the perpendicular from A to L. A to L. Remember that A is part of a line, a straight line. A is part of a straight line. And coordinate of A is 1, 2, and minus 2. Find the vector of the foot of the perpendicular from A to L. And L has equation of 1 minus 1, 3 plus mu L, mu, that's 2 minus 3, 4. So what we have to do is to find the position vector of the foot of the perpendicular. When you check the diagram, this is this line from A to L is perpendicular. The foot of the perpendicular from A, so let's call this place N. From this diagram, you can see that AN is perpendicular to L, and also N is on the same position as L. N, the one I label N here, is on the same position as L, which means N, which is the same thing as ON, we take the same vector equation as L, which is 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu. Remember I said AN is perpendicular to L. So, and we don't have AN, we don't know AN. So, but AN can be calculated using ON minus OA. So, AN is equal to ON. ON is 1 plus 2 mu minus 1 minus 3 mu, 3 plus 4 mu, minus OA. OA is 1, 2, minus 2. So therefore, AN, after you subtract them, AN will be 2 mu minus 3 mu, 5 plus 4 mu. That's AN. Since AN is perpendicular to L, which means AN dot L will be equal to 0. AN is 2 mu minus 3 mu, 5 plus 4 mu. Dot L, that's the line. So what we use in the line will be the direction of the line, which is 2 minus 3, 4. Is the direction you always use when you are doing perpendicularism between a line and a vector. It's the direction of the line you choose equal to 0. So from here we have 4 mu plus 9 mu plus 20 plus 16 mu equal to 0. So at the end of it, we have 29 mu plus 29 equal to 0. So here, mu is minus 1. So when mu is minus 1, so we can now get AN. So AN will be, AN is 2 mu, 3 minus 3 minus 3 mu, 5 plus 4 mu, and our mu is minus 1. So AN, our mu is minus 1. So our AN, which is, so AN will be minus 2 minus 2 minus 3 minus 3 mu minus 3, that will be minus 3 plus 3. That should give us, trying to cross check, minus 1 minus 2 is minus 3. This one should give us 0, and this should give us 1. And the question asks us to find the position vector of the foot of the perpendicular from A to L. The N is the foot of the perpendicular from A to L. So foot of the perpendicular is N. So the vector equation I'm looking for is AN, which will give us minus 2I plus K. That's it. So sorry, the foot of the perpendicular, that's ON, not AN. The foot of the perpendicular is ON, not AN. So let's correct it. The foot of the perpendicular is ON, not AN. So from here, ON, which is the foot of the perpendicular, which is 1 plus 2 mu, minus 1 minus 3 mu, 3 plus 4 mu, becomes mu is minus 1, right? Mu is minus 1, so it becomes minus 1 here, minus 1 plus 3, that will be 2, right? Minus 1 plus 3, that will be 2, and 3 minus 4, that will be minus 1. So ON, the vector equation will be minus I plus 2j minus k. Thank you. That's the solution for the second part. Please subscribe to my YouTube channel. My next video will be on Physics Paper 2, Variant 1, 2023 in next few hours.